Hello. Now in this video we will see one more example of construction of orthographic to isometric view of a solid. As on the screen you can see that the front view and top view of a isometric solid has been given. So based on these two views we need to construct the three-dimensional view. If you observe carefully, this isometric solid consists of three individual parts. So first one is the base, which is having this shape, the base. Here you can see this is the base 1, and the second part is a square block on the top of this base. Just you can see here, this is the second one, and the third part is a rectangular hole of dimension 16 by 22. So how I said is a rectangular hole? On the top view it appears as a visible line, but on the front view it appears as a hidden line which represents a hole in the base. The moment we see the question, immediately to calculate the dimensions, draw the projectors from the ends like this. So with the help of these projectors we can calculate the dimension of each and every segment. So from here to here it represents the 75 mm length. So from here to here 75, but this distance is nothing but 11. So from here to here the distance is 11, and from here to here the distance is 11, but he has not given, but on the bottom side you can see 11. The same applies here also. So from here to here 11, from here to here 11, and now this length will be the 75 minus 11 will be the 64, 38, 64 and then 11, and this is the 16, exactly from the center, 8 mm above and 8 mm below. And already the top one, which is the square block, the width is, you can see from here 22. Already this length is 22 and height of the block is 15. So we know the dimensions of this one also. And coming to the third portion, you can see the width is 22 and here 16, and the depth is 12 mm, and the depth is 12 mm. So with this we know each and every dimension. Let us start the procedure of construction. So first I am going to start with the top view. So in the 3D modeling layout, right now it is an unsaved view. I am choosing the top view. Yes, now the top view plane is ready. First take the line command and switch on the ortho line. (64), (38), (64), and now I need to draw this one and this one. There are two processes you can do. So from the 64 end of the line, draw a line L of length 11 and then 11 and connect these two ends. From this end and this end you can connect, and you can apply the same. And one more method is, this is a 38, from the mid you can draw a 75 mm line, and above 8 mm you can draw, and I am going to choose the second one, which is will be easy. So take the length as 75 mm, and now here 8 mm. So here this is an individual line of 8 mm. So next, don't draw a line of length 8 mm again. Just click it and place the cursor here. It will ask you to stretch or lengthen. So I am going to stretch 8 mm. Yes, now this is a single entity. Now connect these lines. Yes, now the base part is ready. Select all the lines and then join to make it as a single plane. Yes, now it is a plane. If you go and see the southwest isometric, yes, now the bottom base is ready. Again I am going to top. In the previous videos I constructed different solids step by step on the one by one on the top. But in this video, I'm going to do a different procedure. You can see that on the top view, it appears as this one, and also a rectangular block and a hole. It is difficult to place one on the top and to cut here because so much of dimensions are there. That's why I'm going to follow a different procedure. If you see, this a square block exactly lies at a distance 8 mm from here. You can see 8 mm from here and 8 mm from here. So now the same I am going to do. Take the line. Right now it is in plane only. I didn't extrude it. 8 mm and then 8 mm. Yes. Okay. I gave the coordinates of this point. 8 mm, 8 mm. This is the coordinate. And from here I am going to start 22. You can see the dimension 22 and then 22, 22, 22. Take the polyline instead of making with the lines and then joining. 22, 22, 22, 22. Because of the polyline, now it's a single entity. Yes, we made the second one also ready. And now this is a rectangular block of dimension 16 and 22. Now we need this coordinate. So what is the place? If you consider from the top, it is 11 and from here 8. So we can draw a line from here 8 mm, but this distance is 11. Here is 8. Simply you can see here the gap between the square block and rectangular block is 8. Okay, perfect. And now already we have given 8 mm from here, but this distance is 11. So simply I am going to take 3 mm extra. That's it. Now take the polyline 22, 16, 22, 16. See here 22, 16, 22, 16. We made it. See, now this is a single plane and this is a single plane and this is a single plane. Now we'll draw the construction, delete the construction lines. No need. Yes. Now we'll go to the southwest isometric. This is the exactly the top view what we saw. Top view is ready. So based on this top view, first I am going to construct the front view. So here in the front view, the height is 12 mm and the square block is placed above of it. So now I am going to take extrude, select this one. Yes. So I am going to downwards because this square block should be on the top of the base. So that's why I am extruding in the downward direction. Instead of above the direction, I am extruding in the bottom side. 12. Yes. And now the square block height is, you can see, 15. Extrude. If you drag it down, it will merge into the solid, but we need this 15 mm above the base. So 15 mm. Extrude in the upward direction. And now this rectangular hole should be made in the base. So that's why again take the extrude, select the object, enter. Now don't give in this direction. We need to take this side. So 12 mm towards the downward. Yes. Now if you see in the realistic or X-ray approach, you can come to know. Yeah. Now SUB, subtract from this one. Yes. Now perfect. Select these two and then union. Okay. Select this one and this one. Now this is a complete solid. If you see the front view, perfect. You can see like wireframe perfect, as like we saw in the question. But hidden lines you won't be seen in the 3D modeling tool. There is no such facility here. And now you just see in the top view. See, the top view also remains the same. Now we'll give the dimension. Before giving the dimension, go to the layout. Yeah, it is in southwest isometric. Okay, first we'll click the southwest isometric, layout tool. Okay, I'll create one more layout, no problem. Yeah, but here, as I said, here you can see only the visible lines, but actually this solid consists of visible and hidden lines, as been seen in the previous videos. Click on the paper, select the pan command, move it aside, switch off the grid. So before importing, click on the right click, drafting standards setup. Choose as first angle projection. Don't choose third angle. Let it be first angle projection. Okay. Base from model space. Place it here. Enter. Just click it here. Okay, this is not the right way because some details are not so clearly visible. Base from model space. I am starting from here this time. Enter. Click it here. Yes, this is the correct one. As we know,